Okay, so we're talking about Hooke's law again and stretching springs. First of all, I want you to imagine that I have a spring that's 10 centimeters long. That's its natural length. It hasn't been stretched yet. It's just sitting there. Natural length, 10 centimeters. So in my table here, I've recorded force 0 because there's no stretching force yet. And I've recorded total length 10 centimeters because it's 10 centimeters long. For extension, I'm going to record 0 because it hasn't been stretched yet. Then I want you to imagine that we take the spring and we hang a 1 Newton weight on it, like so. Obviously the spring is going to stretch, and now it's got a total length of 30 centimeters. So I say 1 Newton for the force, 30 centimeters for the new total length. If the new total length is 30 centimeters and the spring was originally 10, then we can work out that it must have stretched 20 centimeters. It's 30 centimeters now. It used to be 10, so it must have stretched 20 centimeters. How did I get that figure? I took the original length away from 30. Now I want you to imagine that I hang another weight on the spring, so the spring now has a total length of 50 centimeters. So I record 2 newtons, 50 centimeters. If the original length was 10 centimeters and now the spring is 50 centimeters long, well then I can work out that it must have stretched 40 centimeters. I want you to imagine now that I hang 3 weights on the spring. So there's 3 newtons hanging on it, and now the total length is 70 centimeters. 70. If the original length was 10 and the new length is 70, if I take those away, then I can say that the extension is 60. That means it is stretched 60 centimeters longer than it was at the start. 40 centimeters longer than it was at the start. 20 centimeters longer than it was at the start. If you look at this row here and this row here, you hopefully can see a pattern. When the force was 0, the extension was 0. When the force was 1, the extension was 20. When we doubled the force to 2 newtons, the extension doubled. When we tripled the force to 3 newtons, the extension tripled. So there's definitely a relationship between force and extension. If we plot force against extension, then here are the results we get. When the force was 0, the extension was 0. When the force was 1, the extension was 20. When the force was 2, the extension was 40. And when the force was 3, the extension was 60. So there's definitely a pattern here. In fact, the graph formed is a straight line through the origin. This shows us that the extension is directly proportional to the force, provided the limit of proportionality is not passed. Now don't worry about what this means yet, just accept it. So Hooke's law says the extension is directly proportional to the force, provided the limit of proportionality is not passed.